How do you do, fellow kids? So your professor isn't here today. I promise I'm just a regular university student like yourselves. So you can trust me. You know, if you want to tell me like the answers to the homework or something, you know, just let me know. It's all cool. All right. I can't keep up that act all lecture, sorry, but that's all I got. Let's turn this thing down, it's so loud. All right, so this week we're going to do, what do I even call this week? Examples in architecture. So this week is examples in architecture. So it's a pretty open-ended week. So if there are things you want to see, we had a few suggestions last time of streaming and how a browser works. I have full intentions of studying up on those and talking about those on Friday in more in depth than I did. Like I talked about streaming, kind of just ad-lib for a while. But I do intend to, no promises, just in case I get caught up in other stuff. But I do want to do some live coding today and show you how to organize a server. That's what I want to focus on today. Yeah.
Anyway, are we all done
fine.
with homework 3's material? Unit 3 is all done?
Yeah. Yeah, so at this point, you know everything you need for homework 3. I'm going to use this week to kind of talk about other stuff. It won't be homework 3 stuff. Unless you have questions about homework 3, I'd be happy to answer your questions still. But this is kind of open-ended content, I should say. Things that don't really belong in one of the homeworks. Things that I can't find a specific location for. I don't know if that's the right way to phrase that, but... But yeah, let's talk about this. So what I want to do today is talk about the structure of your server. If I can resize this in a nice way and get the browser set up right here. I say things kind of off the cuff throughout the semester. And it's hard to find lectures where I can jam this content. So right now is the time where I want to talk about it. Of how to organize your code. One thing that I've said a lot this semester is writing a method that parses your headers and puts them all in a key value store. But I also want to talk about something I haven't talked about much this semester that I've harped on in the past a lot, which I've made mistakes. I'll just be upfront about this one. I've made mistakes in the past where I talk about it too early, and then students try to implement it on their homework, and it just gets them in trouble and confuses them. But now it's late enough in the semester, you're 2 homeworks in, that I want to show you a better way of organizing your server code where you don't have this giant if, elif, probably got quite a few elifs by this point, and then an else with a 404 at the bottom. I recommend doing something better. I haven't recommended it too much this semester because I'm waiting till today. But I want to show you how to set this up in a better way. A way that's going to see a lot of benefits. You know what, let's just get into some coding. You'll see the benefits as we go. So here's the server. This is a server that I showed the very first time I showed a Python server. Sorry, those of you not doing Python. This will be all in Python. This is the first server that I ever showed. We receive some information. We send hello. Doesn't really do anything. And we're going to make this do a couple things. With I want to turn this down a little. With a focus on the structure of our code. So let's get this to do certain things. And first, I meant to delete this line. I meant to delete this and do it live. So we're officially starting with the very first server that I showed you. The first thing, I mentioned this last time, I want to remind you, because it's something that's been saving me a ton of time and it can save you a ton of time, if we do socket server dot TCP server dot allow reuse address equals true, this is going to get rid of that issue where we're constantly getting that address already in use when it's our own code that was using that address. It's a pain to be able to see that all the time, and then like change port numbers and stuff like that. We're going to get rid of that by setting this to true. This is a class variable for those of you wondering. No, I'm not going to be able to find it, am I? Oh, here it is. This is a class variable. So I'm in the class for TCP server, and allow reuse is false by default, and I'm overriding that class variable, as opposed to state variable. I'm not in 1.16. It takes me a bit to break out of that 1.16 habit. But as opposed to a field in the object, in objects that are created. So self.socket, there's no self.allow reuse address. This is a class level, not object level variable. So we're going to the class itself, which our threading TCP server extends TCP server, so we inherit that class variable, and we're setting the value of that class variable of the base class to true, if anybody's wondering what's actually happening there. And then our server is going to read that variable and say, oh, we're going to relinquish that port as soon as we close. So that's going to save some time, but now let's get into some good stuff. So I'm reading data from my server. We're going to do homework 1. I intend to do at least objective 1. That'll be enough to show the structure. And then objective 2 if we have some time. We might not have enough time for that one. But I'm receiving this data. I want to process this and send an appropriate response. So let's just get some baseline code out there first, and then we'll worry about what to do about it. So the very first thing, I haven't done live coding in this class in a while. So the very first thing we want to do is look for this blank line. So we have a blank line character. It's going to be our /r/n/r/n. And we want to look for this to be able to separate the headers and the body. So I'm going to look for this. I have to look for it in bytes. So I'm going to take my received data. I'm going to assume it contains, well, homework 1, I'm going to assume that it contains my entire request. I'm not going to do buffering and all that right now. I only got 50 minutes. So I'm going to look for blank line dot encode. So I'm going to look for it in bytes. That's going to give me the index of the first occurrence of this blank line. I'm going to blank line index. Yes, that's a good name for it. So I'm going to get the index of where that blank line is, and this gives me the ability, this gives me the ability to separate the headers from the body. So I'm going to say headers equals received data, and then I'm going to use Python splicing to get everything up until that blank line index. The splicing is inclusive of the start and exclusive of the end point, so I'm not going to get that /r, the byte at that location. I'm going to get everything before it. Python splice, if you're not familiar with this, and some of you got tripped up over this because I use it in my HTML template code. This splice is going to give me everything from the first index up until the second index exclusive of the value at the second index. If you don't put anything before the colon, it's assumed to be 0. If you don't put anything after the colon, it's assumed to be the end of the array. So I'm going to get everything before the array, and then everything after the array, or after that index, receive data. And there are other ways to do this. A lot of you do this with split and then give it a 1 as a second argument. For whatever reason, I just don't do it that way. I do it by indices. So I want everything after that blank line. So I'm going to do blank line index plus, and I could hard code 4. I'm not going to do that. I'm going to do the better way. Blank line dot, Python. Length of blank line and then colon. So I'm going to get the blank line index, the index of the first byte of the first occurrence of this blank line, which is my separator from my headers to my body. I'm going to add the length of this string to that to get the first byte after that, which will be the first byte of the body, and then get everything up until the end of this array. So I've successfully split my headers and my body, and I can start parsing them separately. Next, I want to split my, this is a little bit of a misnomer with headers, but I want to take my headers, get my request line and my headers parsed separately. So headers, this is where I can use split. Let me decode this as well. So my headers, I can safely decode this. Headers are always going to be ASCII text, so I'm going to decode that as a string. My received data is in bytes. I'm going to find this blank line in the world of bytes. I'm going to split in bytes. And then my headers, I'm going to decode into string, and I'm going to leave my body in bytes, because my body might contain an image somewhere. I don't want to mess that up. I want to build this code in a way that's going to be suitable for future homework assignments when users are uploading images and anything else they want to upload. I'm going to leave the body in bytes, but the headers I'm going to leave in, I'm going to decode into a string. I'm going to split this on new line. I didn't define it yet. What's up? No, I'm going to leave this as a string, and I decoded here, so headers are a string. So I'm in the world of string parsing here. All headers. Oops. Request line is going to be all headers of 0. And I could do some error checking here if I were to make this more robust. I would make sure that all headers has size length at least 1, because I am hard coding an index here, which is always dangerous. I'm going to be a little dangerous here and assume that I at least got 1 value out of that I didn't split the empty string. I think that would still return an array with just the empty string, though. But my request line, and then my headers, I'll say all headers. Ooh, I don't remember how to do this in Python. Minus, no, that's not it. I'll just do it a different way.
Is all headers a list?
Is all headers, yeah, all headers is a list. Oh, I backed myself in a corner with this one. For I in range of 1 to length of all headers minus 1. That should do it for me. In range of 1 Python. That should do it for me. That way I don't have to think about how to remove an element from a list. That's where I'm going to parse my headers, and I'm going to parse my request line. So at this point, you've all done code that's similar to that. At this point, I want to start thinking about the structure. So I'm going to have all this code that's just sitting here in my handle method. And in general, what I would like to achieve is for my handle method to be doing almost nothing. I want my handle method to defer to other modules to be able to do the heavy lifting. I want to start separating this code, make it as modular as I can. And when it's modular, it's a lot easier to test. It's a lot easier to use. It'll be a lot easier to read my code. It's going to be a lot easier to just do anything. So what I want to do is get rid of all this. We'll finish it up as well. Maybe I should finish it up now. No, I want to start talking about architecture. And get rid of all of this stuff and get it in a separate module. In this case, module is a pretty overloaded term in computer science. I just mean I want it somewhere else, in this case, in a separate Python file. So I'm going to put it in a file called request. And I'm actually going to create a class. Oh my goodness, I can't spell. A request class. You don't use parentheses there. In Python. I'm going to create a class for my requests, which are going to handle all of my request magic for me. I'm going to create a constructor, and I'm going to have the constructor take in those bytes that I've received. Byte array, how do you do arrays in Python? Oh, I think it's just bytes, actually. If you haven't done this before, Python does support something called type hints, which I strongly recommend. Python doesn't have any strong typing at all, but you can give these type hints in the same syntax as a lot of other languages specify their types, including Scala. So from 1.16, you should be familiar with that. And it'll get your IntelliJ in this case, it'll give your IntelliJ some, not IntelliJ, PyCharm, some idea of what you're trying to do, so it can help you out. It can say, hey, look, you said this was going to be bytes, and then you used it as a string. That's a no-go. Like, what are you doing? So this is going to help me write better code, because I'm going to have some help from my IDE. If I can get the right order of parameters here. Some help from my IDE. And then I want to parse those bytes, doing all this stuff. So I'm going to rip that out of handle, put it in right here. Speaking of class variables, I'm going to create a couple here, because those are constants. Request bytes, request bytes, request bytes. Blank line. Do I really have to do request dot? Blank line, new line. And now whenever I start parsing these things, I'm going to set them as fields of the object. Yeah?
Are you making a mechanism that takes the first 2048 bytes and whatever, and just pulls out all the headers from it?
Yeah, so what I want to do is request equals request of received data. You're
just kind of splitting it up a bit more to make it more generalized?
Yes. Oh my goodness. Yeah, so I want to split up my code. One, so I don't have just a giant handle method with all of my code, which some of you might say, what's wrong with that? I'm going to tell you what's wrong with that. Is when I have my code separated like this, one, if I need to parse multiple requests, I can just create more request objects, and it'll do my extra parsing for me. And if I have this really modular, which I'm not going to go this far in today's lecture, but if I have this really modular where each thing that I'm doing here is a separate method, for example, what we're about to do with parsing the headers here, if this is its own method, then by the time I get to multi-part request parsing, and I need to parse headers a second, third, and fourth time by the time you get to Objective 5 of Homework 2, I'm not cut and pasting my header parsing code multiple times. I'm just calling my method multiple times. Once I get the headers for a multi-part form request, in fact, in my solution server, once I get an entire part from a multi-part form request, I just shove it back into my request, have it do all the parsing for me. I have a way of saying this request does not contain a request line, because the multi-parts won't, and then just have it parse everything for me. Just reuse my own code that I already wrote. Because you already parsed headers that are separated from content with a blank line. You already did that. Don't write that code again. just have it separated in a separate module and just call your code again. This is a fundamental programming concept that we want to embrace because it will save you tons of time. So I'm not going to go that far today, but I'll show you at least the idea so you can get some ideas here. This I want as a variable. So in Python, anytime you do self-dot, that's going to create a instance variable or a field for you. So self.body, I want the bytes of the body in a variable because I'm not going to parse that. There's no generic way to parse the bytes of the body. That's going to be on a per request basis. So I'm just going to store those in a variable and let some code down the road handle what the actual body is. But what I can handle is this request line. I'm going to split this into its parts. Request line dot split on space. Request line, request line parts of 0 is the method. One is the path. And 2, HTTP version. I'm going to put those in variables, and then once I parse this thing, I'm going to access those variables and decide what to do after that. And then my headers of self.headers as an empty dictionary, and then for each additional header, actually I'm going to use split. Now that I think about it, because I don't feel like doing this the other way. Dot split on colon of 1. I'm just going to call that parts because I'm sick of naming things. And then headers, self.headers of parts of 0 equals, is this the syntax for Python? Parts of 1. Thank you, IntelliJ, or thank you, PyCharm. So I'm going to split each header and get them in a dictionary. That code that I was saying so often throughout the semester, it's really 4 lines of code. Get all your headers split into a dictionary. And then this dictionary I'm going to use to look up whatever header I need to access. I need to access the WebSocket. Actually, I have one extra thing I want to do here. I want to strip out that white space because that colon can have a trailing space or it might not. I want to get that out of there. If it does exist, get rid of it. So when I get to WebSockets and I need to read that WebSocket key, I'm just going to go to my dictionary and say sec WebSocket key, give me it. And I can do tests here. This is where I would test. Main, pass. So I'm going to go to my, I am printing these out, right? Receive data .decode. I think I don't want to decode it. So then when it comes time to test, I'm going to go to my browser, and refresh. I'm going to get hello, because my server doesn't do anything. I'm going to grab this thing, and go to my main method, paste, request of test input, request equals pass. I love that. I don't know why, but I love pass in Python. And I'm not going to set up my full testing. I'm just going to run this in the debugger on that pass line. And I can look at my requests that I created. This is a GET request, so there's no body. I don't expect that. My headers, I have all my headers in a nice dictionary, all ready for me to read. My HTTP version, my method, and my path. Everything's right there for me, all parsed and ready to be accessed through these variables. It looks like everything checks out there. I'm not going to do formal testing, but it sure looks like that did what I expected it to do. I got all the information parsed the way I want it to. And now when I get here, request is going to have all that information. So let me get rid of a lot of this, and I can say if request.method equals get and request.method, we'll get there, path equals / hello, then return this. Elif I think I will just deviate from homework 1 a little bit here, just so I can get to the bits that I want to talk about. So let's say goodbye and CC 312. Okay. See ya. CC 312 rocks. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14. And C is 4, 4. I just got to get something up here so I have something to talk about. Bear with me for a second. Oh. Else 404 not found. Oops. 4. Okay, so we got a server that does something. It's nothing interesting, of course, but I don't have a lot of time, and I got to get to the elif, getting rid of elifs. Yeah, this is how you get rid of elifs. So I need elifs. Oh, these should be elifs. So I need some elifs if I'm going to get rid of elifs, I just need some elifs to get rid of. So let's get rid of them. First, I like to have a generic, and I think I did show this one earlier in the semester. I like to have a generic generate response method. I'll call it generate response. Just to clean this up a bit, because I hate how this looks as well. Absolutely hate it. So generate response, which is going to take, I like response code, content, let's just leave it at that. And I would also add content type, and additional headers would be 2 extra things I like in this method. Let's keep this nice and simple at this point, and say that the request or the response equals plus response code. I want this nice and generic so I can reuse this code no matter where I'm using it. But why? Wait, why? Might just be because I didn't finish the line. Length of my bytes. For content length, content type, we're just going to say this can only handle plain text. We're encoding, that's going to be the issue. And then the content no, that wasn't the issue. Encode plus content. This is an awful line of code. I shouldn't do this as an example of what you should do. Plus content type, dot encode. There we go. Return response dot encode plus content. Encode. All right, cool. That's not the best line of code, but that's not the most important thing I want to talk about anyway. And then each of these would get replaced with send all generate response 200 OK. Oh, come on. And hello. So now when I'm sending responses, when I actually send the response, I'm only concerned about what I want to send. Like, I'm not worrying about the format of an HTTP response. I want to offload all that, and I would offload this into another module as well. I want to offload that to some other piece of functionality, which is concerned about all the HTTP stuff for the most part, except for the response code. And I'm just going to say, look, I want to send a 200 OK that says hello. And I'm going to make sure that I have my content as bytes. So even if I want to respond with an image, I'm using the same method. I'm just going to give it the bytes of an image, and it'll do the same thing. And I can rewrite all of these. See ya. Four. Okay. So we got that cleaned up a bit. Like, at the very least, I recommend doing that. But we want to get rid of the elif. This is going to be the trickier part. For that, I'm going to build. Yeah, 15 minutes. We can do this. We're going to build a router. I'm going to build a router that's going to keep track of every one of those elifs. So my router. Oh, I missed my colon. So my router def in it. There we go. Is going to have all of my routes, of course. Let's do that first. Self.routes equals an empty list. And I want to store all of my routes in here. And I have to specify how my routes are going to be added. So if I want to add a route, I want to specify three things. The HTTP method, the path, and what I want to do when this is called. The action, I don't know what to call it. If I want to stick with my types, this will be string, and I shouldn't even back myself in this corner because I forget the syntax for that. And then action is going to be a function that's going to take in a request. I'll give it one shot at the syntax. Request to bytes. No, not going to try. I forget the syntax. I think I need to use the word lambda at least once in there. I don't remember. And then I want to add these in my routes. So what I'd like to say, I might have to cheat a little on this one, is create a router. And I want to create this as a variable in my handler class. If you want to add variables, I forget what params this takes. None and none. Why you give me issues? That's why. So this is something that might help some of you. If I want to show it this way, just in case this can help you, is if you want to add fields to your MyTCP handler class or your MyTCP handler objects, you can add a constructor, but you do have to call the super constructor and give it any parameters that it needs. So if you're going to override the constructor, you do still have to call the superclass constructor. If you don't override the constructor, the superclass constructor is you just get that inherited, and that's what happens. We still want to call that superclass constructor in Python. We have to do that explicitly. So we have to have this code in here. And now at this point, I can add new things. Self.router equals router. So now I can have a router from router import router. If I could type, this would go a lot smoother. Router. I'm leaving that typo. From router, import router. So now I have my router, and I can start adding paths to my router. So instead of having this elif, I'm going to say self.router.addRoute get. Oh man, I'm blanking on the syntax. I thought I'd remember it by the time I got here. A function in Python. Request. You do have to say lambda? Like right here? What is it? Semicolon? Request. I'm just going to cheat. Oh, I used methods. I'll just use methods. That's fine. I'm leaving that typo too. So I'll define these as methods, and then I'm gonna pass methods as my functions. Or actually, these will be functions technically. Hello path, which is going to take a request. So I'm going to define my paths to take a request and then handle that request in any way that we need to. Oh, we also need, no. And the socket. Let me move this too. And then when I want to add a route, I'm going to say, get rid of all this. I'm going to import from simplet paths. Let me just import simplet paths with the typo remained. And then I'm going to give it that function. Or that, yeah, it is a function at that point. And I'm going to do this for each one. Oh, simple paths dot hello. I'll add 2 of these. And that'll prove the concept. I don't really have time to do more. Goodbye path. And I'm not actually using the request for these, but you can imagine paths that you have that use the request, access the values in there. I just don't need them for these simple paths. And then eventually I'm going to get rid of all of this. Oh, I did this a little backwards. This needs to go in the constructor. So I'm going to construct a router and add all my paths to it. And then when it's time to handle a path, did I add that to my router? Bless you. I'm going to handle a request. It's going to take the request and the socket. In my handle, I'm going to say self.router.handle. I'm going to give it the request, and I'm going to give it the socket, which is self. And this is how small your handle method can be. You don't need anything in your handle method. Defer to your router, and when you use frameworks like for your project, this is how simple your handle is going to be. You're going to add the paths, and the router does the rest. And your paths can be specified in other files. You don't need really much of anything in your main top-level method, in your top-level module. And then in my router, I need to oh, shit, I didn't add paths yet. Self.routes.append. I'm going to append this as a list. I'm going to use a little bit of jank here, again, time. I would create an object, like a path object, to be able to do this. Action, method. It's one of them vowels. I'm just going to append it as a list and then remember by index what each value is. And then handle, I'm going to say for path in for route in self.routes if request.method equals route of 0 and request.path equals route of 1, route of 2 of request socket. And then we'll see if we got there. /hello. We didn't get there. Self.. Well, oh, I'm looking at the clock that says 49. It's 47. We can get there. We'll get there. My TCP handler has no object. It definitely does have a router. Yeah, why don't you have a router? In that constructor, maybe we won't get there. I don't know if I'll be able to see it in time. This has to be the first line, right? Or does it have to be the last line? Well, I don't have time to debug this, but it should work and it should be magical. We just didn't quite get there. It's going to be something silly, but that's the idea of how you would get rid of that. Just use what you've learned about programming up until this point in your career, mix it all together, and have some nice organized code. Not seeing what? The lecture question? Did I? Oh, you had me panicking. I have forgot in the past. All right. Have a great day. I'll see you all Wednesday.